Hello, I'm your host, Sarah Webb, and this is Science in Parallel, a podcast about people and projects in computational science. On today's episode, I'm speaking with Quentarius Moore. He's a PhD student at Texas A&M University and a fellow in the Department of Energy Computational Science Graduate Fellowship Program, commonly called CSGF. He completed both his bachelor's and master's degrees in chemistry at Jackson State University in Mississippi. Quentarius and I first talked last year for an article that appears in the 2021 issue of Dexys magazine. This time we talked about the power of mentors, life lessons from working in concrete with his grandfather, and embracing the unexpected, including his emerging career in computational chemistry. I'm really happy to welcome you to Science in Parallel, Quentarius. Thanks for being here.
Oh, thank you so much, Sarah.
Tell me a little bit how you first got interested in chemistry and in computation and these pieces of your work that are now a big part of your graduate research.
I think my story is one that may be strange, but I'm sure it's not unfamiliar with a lot of people. High school, I didn't chemistry, I liked it, but poor student habits. I would do great on tests, but not really focus on the homework because I would go play basketball, play video games, all that. But once I got to college, I decided to stick with chemistry because I knew I like to solve problems. I was able to join a few programs, which allowed me to have mentors, which were a great help for my development throughout undergrad. And so the first program I was introduced to, we had this mentorship where we had a cohort. It was a graduate student, a junior, and a freshman, which would be me. And the graduate student, she did computational chemistry. And so that was my first introduction to computational chemistry. And so going through that with her, it really helped my matriculation because, we needed help with different courses or just advancing her work. I really felt a responsibility to bring up my end of the deal with this cohort and aiding her research. She's still a mentor of mine now, even when I went through my master's at Jackson State and currently at Texas A&M.
What was it like to get involved with the computational part of this? You were mentioning that you'd had an interest in video games and things like that, so it's not like computers were not something that you were just spending time with at all, but you were spending time with them in a new way, right?
I'm pretty tech savvy. I'm that kid that when you go to your grandparents' house, they want you to look at tech stuff. So I'm that person everyone asks how to fix this, how to fix that. But I never knew much about coding or anything like that. So that was a very new experience learning how to use Linux and essentially using scripting to your benefit. Because you see it in movies and stuff, you think you have to be this very genius and you need maybe a bit of money to afford certain things. But it really wasn't that bad. And it's really cool to know that you can control a lot of things through just simple coding. And it's something that anyone can pick up.
Clearly, you didn't come in thinking, "Oh, I'm going to be a computational chemist," but here you are, right? How did you get from where you started to where you are now?
After the beginning of the peer mentoring process, I actually was introduced to another student who came in as a graduate student, and his name is Chris Copeland. So Amina Muhammad and Chris Copeland were basically my mentors all through undergrad. So he would help me a lot with coursework. So we became colleagues, explored different conferences, and we were big at Jackson State, was the students in particular. We were big on like going to almost any conference that we could because we wanted to one present our research, but also experience things because you get to see so many different people that you don't see at Jackson State. I always assume once you get a chemistry degree, you become like a lab technician or something. I had no idea until I expounded about past Jackson State and looked at what other people do. And so I made up in my mind, hey, I think I want to get a degree in chemical engineering. And so towards the end of my senior year, I'm like, well, I'll apply to a graduate school and get a chemistry degree. And so I applied to Florida A&M and Florida State's dual program. However, I didn't hear anything back from them. And so this is around April, but maybe a month before graduation. And so as I'm getting to that point, my grandmother passed in April. And then so I started staying with my grandfather for a bit. And so I'm still waiting on Florida A&M, Florida State to contact me back. And they finally did contact me, but they want me to take this course over the summer in order to make sure I basically qualify to attend the program. But they weren't paying for anything like lodging or whatever.
Right?
And I was like, yeah, that's not going to work. I don't have a job for that. My family doesn't have money for that. And so interestingly enough, I think my catapult to really doing what I'm doing now started with being a concrete finisher with my grandfather. Undergrad, yeah, I did a lot, but I think that work ethic and just determination started with my grandfather. And so after my grandmother passed, I would stay with him, one day, stay with him the next day, the next week. And anytime I would try to leave, he was like, "Are you coming back?" I was like, "I guess I have to come back. The man doesn't want me to leave." And so he was very concerned about, what was happening too. So he was like, "Well, why don't you come work with me during the summer?" And so I worked with him, hot Mississippi summer, working concrete with the 78-year-old man. Surprisingly, he's still out there doing it. A lot of what he told me on the site really still resonates with me because he would always tell me, even though I'm the young buck, he would tell me, "Take your time, take your time, take your time." I'm trying to help him, but he's still telling me, just take your time. And so he would repeat that like all throughout the summer because I'm thinking, since I'm stronger, younger than him, I should do more. I should do it a bit quicker just to help him. But he would always say that. And one of the best moments that I had that summer, I think this does relate a bit to peer-to-peer mentoring. My grandfather knew I wanted to start a garden. I had a shovel. I'm digging holes through this like 20 by 20 field. Well, I say little plot. And I'm digging and digging. I have a wheelbarrow. I'm shoveling, cow pies from the pasture to I'm thinking I'm gonna fertilize before I plant and all that. So I'm doing all that every day, planting a garden. It wasn't a little garden, it was a huge garden. And so I was like, yeah, this is gonna be tough. So I found a rototiller that still didn't do much. And so I went to sleep one night after work and tending to the garden. The next morning, I woke up to just a tilled garden, row upon row upon row of what you think a garden looks like before you plant. Like he took his tractor and tilled it for me, which really it really touched me because I wasn't expecting it. He didn't say anything about it. I just woke up one morning at like 6 a.m. and I went out there and I'm like, huh, I don't see any grass. And so he literally plowed and tilled the whole thing for me, and that really, I don't know, that just really resonates with me as far as peer to peer. That's what happens with peer to peer. Like they see you working, they see you determined. They don't have to tell you everything, but when you really need it, there's someone there to help you. And so he really did that for me. And so towards the end of that summer, I realized, yeah, this Florida thing isn't gonna work. I have no idea what I'm gonna do. I enjoy staying with my grandfather and doing the concrete with him. I think it might have been August already. So Chris Copeland, I don't know how we got on the subject, but he was like, "Yeah, Q, why don't you just get your master's in chemistry here?" And so I applied and got into the master's program. And everything blew up from there. Honestly, everything blew up from there.
And then you came back to this environment with a different life perspective. Losing your grandmother, spending that time with your grandfather. How did you approach those years at Jackson State when you came back?
I got into this fellowship called the Lewis Stokes Alliance for Minority Participation. And I got into specifically the subsection called Bridge to Doctorate. And what this program does is it basically funds students through their masters with the expectation that you go and pursue a doctorate. And so for those 2 years at Jackson State, it was really nice having that another peer group of other students doing the same thing I'm doing. We weren't all chemistry or even yeah, we weren't all computational chemistry or even chemistry because we had mathematics, we had environmental science, we had computer science, and then you kind of had a bit of a cohort system again. And so we did a lot of interacting with them. We went to a ton of conferences. And that was one way reason I even ended up at A&M in the first place because um, we're part of what's called the National Organization of Black Chemists and Chemical Engineers, and they have national conferences. But I found out through my master's that they have regional conferences, and they had one at LSU. And so people from my fellowship decided to go, especially the chemistry students. We decided to attend and present some work. And so I go down there to LSU. I'm presenting my work that I did at the University of Alabama when in my undergrad. So I'm presenting my work. I'm telling a story about this experimental stuff I was doing, how I used to sing to the instrument. I used to play Bruno Mars on on Pandora every day and just, relax, sing to it. Hopefully it worked. And so I get through with the presentation and, I'm just minding my business because I'm pretty nervous, when I'm presenting. So I'm just kind of, winding down. And this guy comes up to me out of the blue. He didn't ask me about the work. He asked me which song from Bruno Mars would I sing to the instrument. He's not a student.
Right.
I can obviously see that. So I answered him. He was like, "Oh, that's cool. Can I show you what we do in my lab?" And I'm like, "Well, yeah, why not?" And so he whips out his laptop out of his backpack, sits down. He's just showing me just slides of stuff that they do in his lab. And the cool thing about the fellowship is that they supposedly they give us a stipend, obviously, to matriculate through our masters. And so as he's presenting, I stop him. I'm like, "Hey, what are you doing this summer?" He was like, "I don't know. What are you doing this summer?" So I said, "Well, if you can give me a place to stay, I would love to come to your lab for the summer. I think I can make a way to where I can take care of my own stipend. I just really just need a place to stay." And so this guy that I was talking to is Dr. James Petit, my current advisor at Texas A&M. We literally got hooked up through just some random happenstance where he was nice enough to come ask me, "What song from Bruno Mars did you sing to the instrument?" And and it all and it all blossomed from there. And things like that obviously wouldn't have happened if Chris or Mina didn't help me out, and especially if Chris didn't tell me, "Hey, go back to Jackson State."
Right.
And what topped it all off was getting the DOE fellowship. That really topped it all off.
So tell me about the decision to apply for it. You still have to submit
Yeah.
the application, right? I mean, you have to say,
Yeah.
"Okay, I'm putting myself out here." So what how did that happen?
Through undergrad, just seeing us always go to conferences and apply for stuff, that's how I even got the internship at University of Alabama. It was a chemical engineering internship, and I'm a chemistry major. I was just like, I'm going to apply to every single thing I can find. I want to get an internship because I have no idea what I want to do, but this may help me. I may not get any of them, but I'm going to apply. And I applied to about 15 different things, and then surprisingly, the chemical engineering one is what came through. The advisor that I had there, he even asked me, posed this question, why not get your doctorate? And didn't have a reason to answer him of why I didn't want to get my doctorate. And I really appreciate him too. His name is Dr. Hung Tao Wong. And so every time I applied to things, what's funny is that I never really had confidence on getting it. It's like, let me just try. Because once you read it, you get intimidated on like what it's about, what do you have to do, and then you see kind of the people who've been through it before. You're like,
So
man, I
this is
don't
now the
know.
CSGF, I guess.
Yeah, this is the CSGF. I'm like, I don't know, but I'm thinking this will help me with my journey through this doctorate program because I don't have experience of what it's really like to go through a bigger school's PhD program. It's a bit different, especially with funding and trying to have mentorship and just all the things you need to be a successful student. I had no idea how that works. But I told myself I at least need a network of people to lean on to get through the program. And so I went through the process of applying for it. So it really was just a testament of trying. And that's what I've seen with a few students I've helped a bit with applying. I literally tell them, I know you're intimidated, but just try it. Because I never in my wildest dreams would have thought I'd get the CSGF fellowship. And even when you get it, what's funny, that first annual program review they send you to, everyone in your class is telling each other the same thing. Everyone had that same thought of, I don't know if I really belong here because I didn't think I would get it.
Talk about your PhD project and talk about the parts of the CSGF that have fed into that for you.
The computational work that I'm doing here deals more so with friction, what's called tribology. And that's when you're looking at the effects of friction on the wear and tear of materials, and what we want to look at is how can we, in one way, manipulate surfaces for different tribological effects or properties. So how can we reduce friction? How can we reduce wear? How can we, change the chemical reactivity of surfaces at select sites? That's a very good benefit for real world applications and also for the use of energy recovery. one thing that really helped me from the CSGF is actually the coursework. The coursework was the hardest thing I've probably ever been through in my life. I did more dealing with coding. And so the CSGF really made me go outside my comfort zone with those math graduate courses and computer science graduate courses. And one in particular that I took, which I never thought I would see in my life, is that we took basically an artificial intelligence course. And this whole time, we're basically the premise of the course was we were doing these Pac-Man projects. We were doing these different AI techniques to program Pac-Man or even the Ghost to do certain tasks or like beat certain levels in a certain amount of time or with certain efficiencies. And throughout all this coding, this kind of gave me a lot of like further ideas for my research. Here, I want to implement more machine learning to our data analysis. So the AI course and my statistical analysis course, it got me thinking more. What more can I do? How can I add to my research?
Tell me about your work at Sandia because I know that's been a big part of what you do, the work that you've done out there.
I decided to do a practicum my first summer instead of waiting, what they recommend your second summer. So I decided to work with Sandia due to Dr. Batiste already having a bit of a relationship with Sandia with his previous student. And he recently gained connection with Mike Sandross through the tribology work that they're doing, dealing with molybdenum disulfide, MOS2, and looking at its tribology properties and how it's affected by atmospheric exposure to oxygen and other radical species. I go out there my first summer, and it's interesting because I honestly didn't know that national labs existed, and so going there was honestly pretty amazing. There, Sandia was very open and friendly because you can contact anyone, and so the coursework that I did through CSGF, it got me thinking about more so not just like regular scripting for data analysis, but like the machine learning aspect, other things that are becoming very big in computer science. And so I was actually able to reach out to another staff member at Sandia through the email network and just pick his brain a bit about what he does and through machine learning. And he was nice enough to meet with me. We chat. We still stay in contact here and there, like every few months. And just experience with Sandia is very different. And you get to see all types of people doing all types of work, but how it flows together, this interdisciplinary thing where you don't have to put yourself in a box. And the practicum kind of gives you a feel of the many things that a computational scientist is. You can basically have all the ideas that you can imagine. You can actually take the time to try and connect those. You don't have to stick with one thing.
What are kind of the core science questions that you're working on now? What are the key questions you want to answer with the rest of the time that you're working on your PhD?
A few of the core questions that I have with my remaining time in my program is one still the work with Sandia. We were looking at chemical reactivity effects of MOS2 when it's exposed to different radical atomic species. And so one thing about MOS2 is that it has very cool tribological properties, which we think of as frictional properties. And so we use that as a solid lubricant in different machinery, and it's been around for a long time. But now when we think about, SpaceX and exploration, that's one material that can be used as a solid lubricant in space. 'Cause you can't use liquid lubricants in space. And so that's how you get around that. However, you do have to focus in on a bit of the drawbacks of using a solid lubricant like MS2 in space. Because one, you have to deal with storage. Like how long, let's say the satellite is stored before you launch it. What environmental exposure does it have when you're launching it, and also in space? Like how does radical species affect not just the structure but the electronic properties of this material? And that all plays a role in tribological properties. And so with that, we're working on how can we actually control the chemical reactivity in the surface of MOS2 before and after it's been exposed to water and atomic oxygen. And one further thing to that we want to look at with that is how can we control these chemical reactivity using curvature? Because what typically happens with MOS2 is that it's laid on a metal surface. So there's an interface. And different types of metal have different roughnesses, as you can think of like hills and valleys on the surface. And so how does that play a role, but also understanding how can we manipulate that and induce certain reactivity on the surface using curvature. Typically with reactions, you supply some type of heat or some type of current to induce this chemical reactivity. And so we're looking at more of a mechanochemistry standpoint of how can we mechanically drive chemical interactions. And so not just dealing with the wear and tear of MOS2, but also how can we fine tune certain aspects of MOS2 by using mechanochemistry. And so that's one question with on the Sandita aspect. And that kind of funnels me on to our second question, which deals with mechanochemistry, not just tribology. And so in this mechanochemistry sphere, we do have this new center called CMCC that we just got the center grant.
That new center is the NSF Center for the Mechanical Control of Chemistry. Quentarius's PhD advisor, James Batiste of Texas A&M, directs the center, which includes nearly 2 dozen researchers from 6 institutions.
And with that, we're looking at another 2D material called graphene. And so we're doing similar things with MOS2, but we're doing a certain reaction with graphene where we're looking at its interaction with this radical molecule called 4-nitrobenzene diazonium, very reactive. And so what we're looking at with that is since graphene is more so atomically a single plane 2D material, how's the reactivity with it and what's called 4BD change through the use of out of plane strain? Because we've seen that when you compressively strain, which is essentially squeezing of the plane, or tensile strain, which is stretching, the chemical reactivity doesn't change much. But we've seen that when you induce out of plane strain, which is kind of like poking at a piece of paper from the underside of it, when you induce this out of plane strain, some interesting things happen with the chemical reactivity of graphene. However, it's vaguely understood exactly how and why that occurs. And so that's where the computational aspect comes in. And so we're able to do experiments and also and validate models that I produced through our computational methods, and also use those computational methods to drive more effective experiments. And so it's like the synergy that we have in our lab. And so answering that second question would allow us to be able to selectively decorate graphene with certain materials because we may be able to drive chemical reactions simply by inducing mechanical strain.
So you could poke and prod something and get it to change its chemistry.
Exactly. And that's the thing with 2D materials. They're very wonderful for their properties. However, they can be very stubborn when you're trying to covalently bond different molecules or atoms to it. And the reason why you would even do that is because you can change its chemical properties to what best fits for the application. And so we want to essentially poke at one spot, plop, and we can plop a molecule. That would be cool if we could do that. A simple deformation, and we can selectively place molecules where we want to. And then my last core question is looking at essentially how can we advance material science through the use of machine learning and other artificial intelligence techniques. When you research past uses of artificial intelligence in material science, it's very young in people's acceptance of using AI and machine learning in material science, like data analysis and all of that. And what typically people talk about is using AI to do data analysis on images. What I want to be able to do is implement more image classification techniques for all of our surface science experiments. Because what we're typically doing is we collect data from the chemical interactions that happen between our surface and our cantilever, our tip. We're recording those interactions, but we can record those interactions and turn them into an image, which is pretty cool to me. I want to be able to apply this image analysis to further amplify the data that we have, as far as one being more effective in the lab, two being able to deduce certain changes in the surface as an effect of changes in parameters. And also, I want to be able to grow it beyond just research science and more so as a public tool to teach regular people about what we do and especially students because I didn't know anything about this, and it's nice to have that exposure. Like, obviously, you're not trying to convert everyone to like a computational chemist, but you want people to be able to understand what's going on and what their future looks like through this research that you're doing and that basically doing for everyone in society.
You have obviously a lot of science that you're working on now and ways that you want that science to reach the public. What are you thinking about in terms of future directions at this point and what might be next for you after Texas A&M, or are you still kind of going with the flow as you have with so many other decisions along the way?
Yeah, that's a great question and the story of my life where I get to say, yeah, not really sure. But what's different this time is I see the options. It's like this Sandia, the National Lab. I like it there. Yeah, I'm not sure exactly what I want to do, but I just see so many opportunities that I've come to realize that the best things are the ones that are unexpected. So I'm very hopeful that it's going to be something great.
You sound like someone who has embraced that all along,
Yeah,
and
I've
so
embraced it because I actually have a fiance and we're getting married soon.
congratulations.
Thank you. She's at A&M and she's in the urban planning department. I enjoy teaching people stuff. I just never saw me becoming a professor. So we've had that discussion where, hey, we both don't want to be professors, but if for some reason that was to occur or be an option, we really would love to become professors at an historically black college or university. And just being able to teach students that come from places like us or look like us, and for them to be able to identify and be able to just get a little bit of nurturing of, hey, you can do it, or hey, I got you, or these are the things that I've seen that you could potentially look at too. And it goes back to that whole mentoring or peer to peer thing. I have no idea if that's going to happen, but that would be a cool option for me, other than working at a national lab, which is an amazing option to me as well. So those two are on the table now. Anything else? If anyone emails me soon after this, I'll be grateful.
I mean, it's a wonderful full circle, right? Because you started
Mhm.
out talking about the importance of mentoring and how important that was to you
Yes.
and the desire to give back. I wanna switch gears a little bit. What's your favorite element?
Hmm. I think my favorite element right now is bismuth, mostly because of how I told you before. I had that internship at University of Alabama. I was literally basically using the oven to create these what's called bismuth telluride nanoflakes, and I feel like that's what jump started a lot of this craziness. That's
It
what
all goes back to bismuth?
Yeah, it all goes back to bismuth. The Bruno Mars, the bismuth, the bees. I don't know what's going on here. But James Batiste, but bismuth is what started all. And so anytime I look at the periodic table, I get this pull towards bismuth. And if anyone has ever seen bismuth on like YouTube where people create the crystals of it, very beautiful.
Do you have a favorite subatomic particle?
I don't want to be basic, but I'll say, but I would say the electron because I have a love and hate relationship with electrons. Because computational chemistry, that's basically so a lot of times what we're looking at on the time scale that I do, such as density functional theory, I care more about electrons. I don't care about neutrons and protons.
Do you have a favorite computer or a favorite processor?
So my favorite computer, which is very sentimental to me now, is the one I built because of the CSGF. Never
Tell
in
me
my
about
life,
it. Tell me
yeah,
about it.
never in my life, but I have thought Quentarius more was building a computer or anything like that. And so the cool thing is that CSGF gives us basically an allowance, and I never used it. And I got the bright idea from the many ideas that I got from like the coursework and just living life. I was like, I can build a computer to do all this machine learning and augmented AI stuff. I should do that. And surprisingly, it went well.
Oh, good. What are kind of the key components of this machine?
I'm very practical. I like nice things as other people do, but I can be very, I'm not saying, I don't want to say frugal, but reasonable. So, you see the shiny things, you're like, oh, Intel processes this and that. I went with AMD because I wanted my allowance money to stretch a bit further and still do great work. And so I have this AMD processor called the Threadripper, which is really cool because instead of just focusing on the machine learning aspect, I can actually do some of the computational work on my workstation through CSGF before I port it to the supercomputer at school. And so my little brother helped me build it as well because during the pandemic last summer, he came and stayed with me in College Station. He didn't do a lot, but he will hold things. I let him screw drive stuff in. And somehow we got it together. It was a pretty fun time, and I never thought in my life that I would be building a computer, and it wasn't that bad. It
Well,
wasn't that bad.
I just love that this was a pandemic project
Yeah,
and a bit of a family project too. I mean, it's just awesome.
that was very fun. And then just piecing the parts together from different places. Like I said, I like to solve problems, so I was like, I have X amount of dollars. Let me solve how I can afford these different components. And so there was a lot of eBay, Amazon, PC part picker and all that.
I love it. I love it. I wanted to ask you what piece of advice that you would give to young scientists or people who are scientist interested. What do you pass along if people ask you?
I think the number one thing that I think a lot of people wouldn't say is don't be afraid to quote unquote bother people. It is okay to go cyber stalk someone for the email address and ask them, hey, I like that you're doing this. Do you mind talking to me? So at least have the gumption and confidence to just, hey, I'm going to try. I'm going to ask. So that's my biggest thing. Always ask for help. And to go beyond that is just find people and because if someone emailed me, I would be happy to help them. If they email and say, hey, Q, I'm in this program, I'm thinking about this and that, I'd be delighted. But on the other side, you think, oh, this person isn't gonna have time for me or doesn't care what I want to do, this and that. Anything you're doing in life, if you need help, ask for it. And if you see someone you're interested in just communicating with, just try, just talk to them, email them.
But we all need it, right? There all of us have things we don't know.
Yes, and all of us do not have like mentors and peer-to-peer help. Not everyone has that. So sometimes you do have to go get it. But once you get it, it's like a snowball effect. Like when I used to think about networking, I always thought about like job stuff. I'm like, I don't want to network or like this is intimidating because this is all about job stuff. I don't feel ready. But networking has more to do with just a peer-to-peer thing. Like if you need help on something, you have people that you can connect with, and it's not really about just career paths and stuff. It's really about mentoring. That's what networking actually is. Now that person may be able to get you a foot in the door for applying somewhere, but ultimately that person is more so a mentor and resource for you.
And with that, I wanna wrap up, and I wanna thank you, Quentarius. It was lovely talking with you today, and I really appreciate your time. It was a great pleasure.
Thank you so much, Sarah. It's always fun talking to you, actually. 'Cause I don't talk about myself much, and it's always an enjoyable experience just chit chatting. I get it from my grandmother.
Well, that's good. I'm glad we could do it.
Appreciate you.
Appreciate you too.
For images of Quentarius's computer and his 20 by 20 garden in Mississippi, and more information about the NSF Center for the Mechanical Control of Chemistry, check out this episode's show notes at scienceinparallel.org. If you like this episode, please share it with a friend or colleague and subscribe wherever you listen to podcasts. Science in Parallel is produced by the Kroll Institute and highlights computational science with a particular focus on work by fellows and alumni of the Department of Energy Computational Science Graduate Fellowship Program, which is celebrating its 30th anniversary in 2021. Kroll administers this program for the U.S. Department of Energy. Our music was written by Steve O'Reilly. This episode was produced by me, Sarah Webb.